Alright, you guys, our first help video of semester 2 for Algebra 2. Quiz 102 is due. So we'll take a look. Some of you have already completed it. Thank you. Excellent. It's not due yet, so don't worry. View and copy. Okay. So actually, we did this in class. So if you were in class today, we would have gone over how to figure out the period of this sinusoidal function. Okay. One of the things to think about here is I like to start here from 0 up down to 20. Okay. 20. The big idea is we need it to make the entire distance. It is the distance from one point and through one cycle of all points. So notice how it's not from 0 to 10. It's not just this top part because it doesn't include all of these values, right? And then if you also think about it, it will just, this period, when you take one period of a sinusoidal graph, you can take that and then just copy, paste, copy, paste, copy, paste, and you'll get the full graph, right? It just repeats after the period. That's the kind of idea behind a period. Okay, we do this whole period and then it repeats. This whole period, then it repeats. Okay? So 0 to 20 on this one. We answered them all in class. And part of it is looking carefully. Like the period here isn't 2, even though there's only 1 square, 2 squares, because the units, the labels represent 2 each time. So one box is 2, the second box is 4, 6, 8, and 10. So when we think about it, I'm on 2 screens. When we start to try to identify what's happening, if you start here at this, say this peak, this would be -3. This would be +1 because it's between 0 and 2. And so that would be 1, 2, 3, 4. So the period here would be 4. And again, we capture the whole thing either from peak to peak or from trough to trough, right? This distance is still 4. The distance, how many units between that trough and that trough, or that valley and that valley. And then if we started, say we started right here, notice on the upswing, so we continue, we follow the graph. There's the downswing. Yes, it's the same point, but it's not, doesn't contain all of the graph. There we go. So that would be from 4 to 8. The distance from 4 to 8 is still 4. So that's the period for this graph, okay? That's how you take a look at periods visually from a graph. Okay. And then again, we answered this one in class. You can start at 0, up, down, like day, night. Okay. Question 2, what is the minimum? So question 2 will ask you the minimum of each of these graphs. Okay. So again, just be careful and look at the, okay, that's hard to read, but this is -2, that is -4. So just where does the trough, the valley, I don't like that word, where does that hit, right? Ooh, okay, be careful. This is -4, this is -6. So what does this line represent? And then again, this is 0, not labeled, 2, not labeled, 4, not labeled, 6. So what does this represent? The minimum, right? The minimum. How do you read this graph? If you don't know, please just ask me so we can talk about it, okay? It's a big skill for mathematics, is being able to read graphs and the tick marks. So this one should be -4. See? Boop. It's right there on the graph. Minimum. Maximum. Maximum, what's the value? The top value? Hey, what's the top value? It's hitting this x-axis. What is the maximum value when it hits the x-axis? Boop, 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 0. It's 0 for that one, okay? We had an example like that. Let's see some of the other ones. Ooh, okay, so read it. Read the maximum value, the peak of these sinusoidal graphs, the peak of the sinusoidal graphs. Again, pay attention to the tick marks, the labels, the units, the scale. Midline. What is the midline of the sinusoidal function? It is considered that equilibrium. So if this was representing the waves, I know, that's terrible, right? If we stopped shaking it, it would come back to rest right here, and then we can start shaking it again. We did it in our science or physics class. We had a long jump rope, and we would try to match different things. It was just a fun exercise. But anyway, that's what's happening here. But the midline is what we would consider when it's at rest. The middle of, okay, I'm trying to see if it's not showing. The middle, midline, middle. So now I like to find the very big top. So that looks like reading this. This is 1 coming down here. This is 7. So from there to 7, 1, 2, 3, 4, 5, 6, 7, 8. Right? So from 1 to negative 7, so from the peak down to the valley or the trough, from the max down to the min, I need to find the middle. Well, this whole distance is 8. So if I divide that by 2, it will give me the middle, even if the middle was a fraction. In this case, it's not. That's 4. So if I go up 1, 2, 3, 4, this should be the midline. And let's check it. 1, 2, 3, 4. Excellent. See? Let's try. 1, 2, 3, 4. 1, 2, 3, 4. It's exactly in the middle between the peak and the trough. Now we just have to find the equation y equals what? Well, between -2 and -4, it's not labeled, but we know it's -3. Y equals -3, okay? So no matter what graph you have, find the peak, find the valley, find the maximum, find the minimum, and halfway in between there, halfway between is where your midline will be. Perfect, -3. Okay? So find it, find the top, find the bottom, find the midline. Find the top, find the bottom, find the midline. Hey, that's kind of nice. It's kind of small and symmetric. All right, question 5 will be the amplitude. Well, kind of the same steps we used to find the midline, only now the half distance, that is your amplitude. Because remember the definition of amplitude? Okay. And if not, that's all right. The definition of amplitude is the height or the distance from the resting position. So from the midline, from some sort of equilibrium, it is up to the highest amount and then down to the lowest amount. They're both considered the amplitude. You can measure either one. So first, I would like to find the midline. So this is -4 up to +6. Okay, so these tick marks are skip counting by 2. That means I need to kind of be a little bit more careful because I know that this is a total distance from the peak, it's a terrible line, of 10. So 10 divided by 2. Oh, no, I don't need to find the midline. I just need to find the amplitude. So if the peak is at 6, that means this is 6 down here. This is -2, -4. There's another 4 down here. So if we skip count 2, 4, 6, 8, 10, we can tell the distance from the peak down to the valley or the trough is 10, right? That's how far apart they are. Then the amplitude is just going to be half of that. So the amplitude of this one will be 5. Hopefully that made sense. I got confused because I was trying to find the midline, and the midline would be a little bit harder because of this scale, because it'd be 1, 2, and then right here is the midline at 1. at y equals 1. That's not what this question is asking you, but this is what my brain went to solve. And see how there's no line there? There's no scale, no tick mark. But this is the midline, and then the amplitude would be from the peak down to the midline, which is 5, the distance, or from the midline down to the trough, the lowest point, the minimum, which would still be 5. Those are considered the amplitude. You'd measure the amplitude from here to here, or you can measure the amplitude from here to here. Okay, awesome job. So this one should be 5. Depending on which variation you have, you're going to have to take your time, try to figure out from here to here, divide it by 2. Or you could see, do you think this is exactly in the middle? Great. Pay attention to the scale. What is this? Is this 1, 2, 3, 4, right? Do the in-between ones, are those, yeah, they are. But you need to make sure you can read that. And then, yeah, be careful over here with this graph. Reach out if you have any questions. Have fun on your first official homework quiz in semester 2 of Algebra 2 in our Unit 1. Great job. You have 3 attempts, different variations, and I'm always available to help. Okay? Awesome.